5.8 goes over solving equations by factoring. When you solve equations by factoring, you have to factor completely in order to even get started. Once you factor completely, you will set each part equal to 0 and then solve for each part. So you will have multiple answers with these. You have to make sure while you're factoring these, you think of every possible way to factor. So first ask yourself, do I have a greatest common factor that I can factor out? If I do, factor that out first. From there, factor the rest. If your A is 1, just factor by finding the factors of your C term that add up to be your B term. If A is something other than 1, multiply your A and your C, find the factors that can replace your B, factor by grouping. From there, if you have a special case, factor it that way as well. If we look at your first example, we have x squared plus x minus 12 is equal to 0. So we're going to find the factors of that negative 12 that add up to be a positive 1. We have 1 and 12, 2 and 6, 3 and 4. We want a positive 1. So if 4 is positive and 3 is negative, we get the positive 1. So we'll use the negative 3 and the 4 to factor this out. We get x minus 3 times x plus 4, keep it equal to 0. From here, you are completely factored. Set each part equal to 0 and solve for the variable. So this gives us x minus 3 is equal to 0 and x plus 4 is equal to 0. From here, we are just going to move the 3 over by adding it to each side, so we get that x is equal to 3. We move the 4 over by subtracting it from each side, and we get that x is equal to negative 4 as well. So your two answers here are x is equal to 3 and x is equal to negative 4. With all of these, if you plug the values in and you simplify, so like for 3, if you want to check 3 as a solution, plug it in and simplify. You should get a true statement. If you don't, you know that that answer is not correct. For our next set of examples, sometimes you are going to have a term on the other side of your equal sign. The only thing that you have to do with these is to get everything on the same side of the equal sign and then factor completely, set each part equal to 0, and solve. If we look at example A, we have 10x squared is equal to 5x. If I move this 5x over, I'm going to subtract it from each side. And you realize that I keep that 10x squared on the side that it already is on because it's positive. And I want that first term to have a positive coefficient. So this is going to give us 10x squared minus 5x is equal to 0. You realize with this equation, for the side that's on the left, you have two terms. So you have a binomial. There's no way to find the factors of your C term that add up to be your B term. So see if you have a greatest common factor that you can factor out first. You do. It is 5x, so we're going to divide out the 5x from each of these terms. We are left with 5x times 2x minus 1 is equal to 0. From here, we're going to set each part equal to 0 because we cannot factor any further. So this gives us 5x is equal to 0, as well as 2x minus 1 is equal to 0. For the 5x is equal to 0, we're going to divide each side by the 5, and we get that x is equal to 0. For the 2x minus 1 is equal to 0, we're going to add the 1 to each side. We get 2x is equal to 1, and then we divide each side by the 2. So we get that x is equal to 1/2 as well. So we have two solutions here, x is equal to 0 and x is equal to 1/2. For example, 2b, we have 3x minus 6x squared is equal to negative 9. Now, my biggest degree here that I have is 2. The term that's attached to that 2 is the negative 6x squared. So with that, I want that 6x squared to be positive. So I'm going to move it to the right side by adding it to each side. And this is going to give us 3x is equal to 6x squared minus 9. From here, I want to move the 3x over as well. So I'm going to subtract it from each side. This leaves us with 6x squared minus 3x minus 9 is equal to 0. I look at this and I first ask myself, do I have a greatest common factor that I can factor out first? I have a 6, a negative 3, and a negative 9. I can factor out a 3 from each of these terms. So I'm going to factor out the 3. This leaves us with 3 times 2x squared minus x minus 3 is equal to 0. From here, I do have a trinomial. That a term is not 1. So I'm going to multiply the 2 times the negative 3. We get negative 6. The factors of the negative 6 that add up to be a negative 1 are 2 and negative 3. So I'm going to expand this to be 3 times 2x squared plus 2x minus 3x minus 3 is equal to 0. When I look at those brackets, I do have 4 terms, so I'm going to factor by grouping. Put a set of parentheses around the first 2, put a set of parentheses around the last 2. The first 2 terms I can factor out a 2x. The second 2 terms I can factor out a negative 3. So this is going to leave us with 3 times 2x times x plus 1 minus 3 times x plus 1. Our 2 sets of parentheses are the same. So this is going to give us 3 times x plus 1 times 2x minus 3 is equal to 0. From here, I'm going to separate each of these parts and set them equal to 0. So I'm going to have 3 is equal to 0, x plus 1 is equal to 0, and 2x minus 3 is equal to 0. That 3 is equal to 0 is a false statement. So I'm going to cancel this out, cross it out, do not work with it. I don't want to deal with it. It's a false statement, so we cannot do anything with it. For the x plus 1 is equal to 0, we move the 1 over by subtracting it from each side, and we get that x is equal to negative 1. For the 2x minus 3 is equal to 0, add the 3 to each side. We cancel out the 3 on the left side. We have 2x is equal to 3. And then divide each side by the 2, and we get that x is equal to 3 over 2. So we have 2 solutions for this one as well. X is equal to negative 1, as well as x is equal to 3 over 2. Thank you. For example, 2c, we're given x minus 4 times x plus 1 is equal to 14. For anything like this where you have a side of your equation that's already factored for you, the only thing that you have to do with these is multiply it out, then move the other side or the other term to the same side that you factored out on, and then refactor and solve. So we're going to multiply the left side here. So x times x is x squared. X times 1 is just positive x. Negative 4 times x is negative 4x. And negative 4 times 1 is negative 4. Now this is equal to the 14, so don't forget about that. We're going to combine like terms here, so this gives us x squared minus 3x minus 4 is equal to 14. I want this equal to 0, so that 14 has to move over to the other side, so we're going to subtract it from each side. This gives us x squared minus 3x minus 18 is equal to 0. We have an a of 1, so find the factors of negative 18 that add up to be a negative 3. If we have 3 and negative 6, we multiply them, we get negative 18. We combine them, we get negative 3. So this factors out to be x plus 3 times x minus 6 is equal to 0. We're going to set each part equal to 0 now and solve. So x plus 3 is equal to 0, as well as x minus 6 is equal to 0. Subtract the 3 from each side. We get that x is equal to negative 3. Add the 6 to each side. We get that x is equal to positive 6. So again, 2 solutions, negative 3 and 6. For example, 3, we're given 2x cubed minus 3x squared minus 8x plus 12 is equal to 0. I look at this equation, I have 4 terms on the left side of that equal sign, and it is equal to 0. So I'm going to start by factoring by grouping. So if I set parentheses around the first 2 terms, parentheses on the last 2 terms, I can factor out an x squared from the first. I can factor out a -4 from the second. So this leaves us with x squared times 2x minus 3 minus 4 times 2x minus 3 is equal to 0. From here, my 2 sets of parentheses are the same. So we have 2x minus 3 times x squared minus 4 is equal to 0. I ask myself, is this completely factored? It is not, because I have that x squared minus 4. This is a difference of squares, which means I can take the square root of that x squared, I can take the square root of that 4. The sign between the two is a negative. So I'm going to have x minus 2 times x plus 2 with this. So we have 2x minus 3 times x minus 2 times x plus 2 is equal to 0. Now I am completely factored, so I'm going to set each part equal to 0. So this gives us 2x minus 3 is equal to 0, x minus 2 is equal to 0, and x plus 2 is equal to 0. I'm going to solve for each of these. For the 2x minus 3 is equal to 0, add the 3 to both sides. We get 2x is equal to 3. Then divide each side by the 2 to get x is equal to 3 over 2. For the x minus 2 is equal to 0, add the 2 to both sides. We get that x is equal to positive 2. The x plus 2 is equal to 0. Subtract 2 from each side. We get x is equal to negative 2. So again, for this one, we have 3 answers. That x is equal to 3 over 2, x is equal to positive 2, and x is equal to negative 2. For example 4, we're told to solve the absolute value of x squared minus 2x minus 16 is equal to 8. With these types of problems that involve your absolute value, you want to make sure first that your absolute value is isolated. Anything that's not in the absolute value bars has to go over to the other side of the equal sign. From there, you want to check to see what it's equal to. The absolute value of anything can never be a negative number. It will always be a positive. So if you ever move everything over to the other side of the equal sign other than the absolute value and it's equal to a negative number, automatically you have no solution. So if we look at this one, it is equal to that positive 8. We're okay. That positive 8 is a good sign. From here, because the absolute value is isolated and we're equal to a positive number, we're going to separate this into 2 equations. One that equals a negative 8, one that equals a positive 8. When we do this, we're also going to get rid of the absolute value bars. So we're just taking both types of that 8, so a negative 8 and a positive 8, to represent all possible solutions here. So this is going to give us x squared minus 2x minus 16 is equal to negative 8, as well as x squared minus 2x minus 16 is equal to positive 8. Once again, I want to represent both possibilities here. So that's why we're separating this into 2 equations, one that's equal to negative 8, one that's equal to positive 8. When I do that, I also get rid of those absolute value bars. From here, you want to keep in mind of what we did prior to this in this lesson. When you're solving equations, you need your equation to be equal to 0 before you can factor. So with working with this equation on the left first, we have x squared minus 2x minus 16 is equal to negative 8. The first thing we're going to do here is move that negative 8 over by adding it to each side. It'll cancel out on that right side. On the left side, we're going to have x squared minus 2x minus 8 is equal to 0. Our factors of negative 8 that add up to be negative 2 are 2 and negative 4. So this is going to factor out to be x plus 2 times x minus 4 is equal to 0. For this, we can separate this to be x plus 2 is equal to 0, as well as x minus 4 is equal to 0. From here, we're just going to solve both of them. So we're going to move the 2 over by subtracting it from each side. we get x is equal to negative 2. We move the 4 over by adding it to each side. We get that x is equal to positive 4. Now we're not done. Even though we found these two solutions, and yes, they are both answers, we still have to finish solving that x squared minus 2x minus 16 is equal to positive 8. So working with that equation now, we're going to move the 8 over by using inverse operations. So we're going to subtract the 8 from each side. That negative 16 minus 8 is going to give us a negative 24. So we have x squared minus 2x minus 24 is equal to 0. Our factors of negative 24 that add up to be a negative 2 are 4 and negative 6. So this factors out to be x minus 6 times x plus 4 is equal to 0. So again, we're going to separate these two, set them both equal to 0. So x minus 6 is equal to 0. X plus 4 is equal to 0. And we're going to solve for each. We can add the 6 to both sides. We get that x is equal to 6. We can subtract the 4 from each side. We get that x is equal to negative 4. So we have 4 solutions here. X is equal to negative 2. X is equal to 4. X is equal to 6. And x is equal to negative 4. Our next set of examples, we are told to solve each equation for y. For example 5a, we're given y squared minus ay minus by plus ab is equal to 0. Our whole idea is to get y by itself. On the left side of this equal sign, we have 4 terms, so we are going to factor by grouping. For the first set of parentheses, we can factor out a y. For the second set, we can factor out a negative b. So this is going to leave us with y times y minus a minus b times y minus a is equal to 0. Our two parentheses here are identical, so we're going to have y minus a times y minus b is equal to 0. Now from here, since we're all factored out, we can set each part equal to 0 and solve for y. So this is going to be y minus a is equal to 0, as well as y minus b is equal to 0. We solve each of these for y. We move the a over by adding a to both sides. We get y is equal to a. We move the b over by adding b to both sides, and we get that y is equal to b. So two solutions here. Y is equal to a, and y is equal to b. For example b, we're given y squared plus 6ay plus 9a squared is equal to 0. Our factors of that 9 that add up to be 6 are 3 and 3. So we can factor this out as y plus 3a times y plus 3a is equal to 0. This is also a perfect square trinomial, so we could have said we can take the square root of that y squared, we can take the square root of that 9a squared, we get y and 3a, and 2 times y times 3a is that 6ay. So it's just the y plus 3a squared is equal to 0. From here, we could start by taking the square root of each side. The square root cancels out the power, and we just have y plus 3a is equal to 0. Again, we're getting y by itself, so we can subtract the 3a from each side, and we have that y is equal to negative 3a.